Good day, everyone. We are back again, and this time around, I want us to touch a little on Euclidean geometry because it's one of the topics in mathematics that it's very, very long and it requires a lot of proving, a lot of reasoning. So, I just want to help you a little on how to counteract these questions here. You probably seen this in your grade 10 modules. This is where you start your Euclidean geometry. So I had to go back to find this here. They might be very helpful in the future when we do grade 12 stuffs, where we have to prove that the lines are parallel, where we have to prove that this angle is equal to this angle, and so on and so on. In grade 10, they told you that if we have two parallel lines and we have a transversal here, in that transversal here, we have these properties that I wrote down here. We have vertically opposite angles, we have corresponding angles, we have angles on a straight line, co-interior angles, and then we have these angles here, the alternate angles. And yeah, let's look at them one by one, and let's start with vertically opposite angles. These angles here, they are equal because they are vertically opposite, like I wrote here. And this angle here, C is equals to B because they are vertically opposite. And then we go here. These two here are equal because they are vertically opposite. These two also are equal because they are vertically opposite. Yeah, you can see that vertically opposite angles are equal only only on parallel lines. If the lines are not parallel, then we cannot say we have vertically opposite angles. But if the lines are parallel, then we can say we have vertically opposite angles. We have other angles here like corresponding angles. Some say it's an N shape, some say it's a Z shape. It doesn't really matter how you remember it, but just know it's one of those two, either N shape or Z shape. So these angles here are equal because they are corresponding. This angle and this angle, they are equal because they are corresponding, like I wrote here. Also, this and this are equal because they are corresponding. This and this are equal because they are corresponding. Like I wrote here, you can write in your notes too. They will help you in future activities. And we have angles on a straight line. We know that angles on a straight line are supplementary. What is supplementary? That means they add up to 180 degrees. So this angle plus this angle is 180. This angle plus this angle is 180 degrees. This and this plus this is also 180. Also this plus this is 180 degrees. This plus this is 180 degrees because they are on a straight line, like this here. And yeah, like I wrote, you can write down this in your notes. And we have co-interior angles. Co-interior angles are also supplementary. That means they add up to 180 degrees. This plus this add up to 180 degrees because they are co-interior. This plus this add up to 180 because they are co-interior angles. And we move on to alternate angles. Some say it's an F shape, which I believe, and yeah, it's an F shape. This here they say it's the U shape. For co-interior, they say it's U shape. And let's go to alternate angles. They say they make the Z shape. So like I wrote here, this and this are equal because they are alternate, this angle here and this angle. also this angle and this angle, because they are alternate. And which other angles? Yeah, like I wrote here, I wrote this here. You can see the alternate angles, they make the Z shape. This and this, also this and this are alternate. That means they are equal. So the most important thing to remember, or the most important letters to remember here is fun. When you see fun, when you see parallel lines, think of fun. What does F stands for? What does U stand for? What does N stand for? F here stands for corresponding angles, because they make an F shape. The U here stands for the co-interior angles, and the N here stands for alternate angles. You must remember this when you see parallel lines. And then let's move on to some properties of triangles. Remember, this is a revision. You did properties of triangles maybe in grade 10, grade 9, and so on and so on. We have four main types of triangles. The first one is a right angle triangle. We know that the longest side here is the hypotenuse. We have 190-degree angle. To find the other side, you can use the Pythagoras theorem. And yeah, there's really nothing much about this one here. Let's move on to equilateral triangle. We know that equilateral triangle, all sides are equal and all interior angles are equal, and they add up to 180 degrees, and all angles in an equilateral triangle are 60 degrees. This is 60 degrees, 60 degrees, 60 degrees, and when you add them together they give you 180 degrees. So everything about equilateral triangle is equal. We have equal length and equal angles. So let's move on to another type of triangle. This is an isosceles triangle. You can see that the opposite sides are equal. If the opposite sides are equal, then their adjacent angles are equal. If here is 40, then also here is 40. If here is 50, then also here is 50, because this here, because these angles here are the angles opposite to equal sides of a triangle. And yeah, there's really nothing. All we have to know about isosceles triangle is that the opposite sides, or the opposite length, are equal. The opposite sides are equal in length, and the adjacent angles are equal. That's what we have to remember about isosceles triangle. We have the last type of triangle, which we call the scaling triangle. In the scaling triangle, we know that all sides are not equal. This is not equal to this. This is not equal to this. And also the angles are not equal. This angle is not equal to this. This angle is not equal to this. So there's nothing equal about scaling triangle. That's what you have to remember about triangles. The last important thing to know is this here. The exterior angle of a triangle. We know that the exterior angle of a triangle is equals to the sum of interior opposite angles. So to find this angle here, you have to add this angle and this angle. They will give you this angle here. You don't add this angle and this angle, no. But if this exterior angle was on the other side, like here, then you would add this and this. Then they will give you the angle here. Just know that the exterior angle is equal to the sum of the two opposite angles, the two opposite interior angles rather. And yeah, in summary, all angles in a triangle add up to 180 degrees, and the exterior angle of a triangle is equal to the two opposite interior angles. And yeah, like go through those right angle triangles properties, isosceles triangle properties, equilateral triangle properties, and scaling triangle properties. They will help you in Euclidean geometry as a whole in grade 12, because like I said in the beginning, we have lots of provings, lots of reasoning, lots of, it's just a lot of things, yeah. But I just want to end this video here because making them very long, they kind of make too much storage, and yeah, it takes a very long time to upload them. So I just want to end this video here, and in the next one we will do some revision or some strategies on how to answer Euclidean geometry, because I did lots of provings in the previous lessons. You can go to my playlist and search Euclidean geometry. You will see all provings that I have done. But for now, I will see you in the next video.